place. So with two possible outcomes, right? So it kind of lends itself perfectly to a tree diagram. So two options, right? She could make it or she could miss it, right? Well, we're looking for the probabilities for makes. Okay. So the first shot, well, she can, if there's a 60% chance she makes it. Well, if there's a 60% chance she makes it and only two things can happen, that means 40% chance that she doesn't make it. That's one shot. Okay. Well, there's more shots than that. The second shot is a make, miss, make, miss. Still 60% chance that she makes it. 40% chance she misses it. That's still constant. That's for two shots. Well, she shoots 3 times, so now I got to go one more event. So each of these is going to have a offshoot. Make, miss, okay, and each of these is going to have 60% chance of making it, 40% chance of missing. Okay. All right. Okay, so what are the possibilities in terms of makes that can happen when she shoots 3 free throws?
Make none.
She could make 0, right? All misses.
Make 1.
Make 1, 3 misses. 2
And a 3.
and 3. She can't make any more than 3 because she's only shooting 3 times. Okay, so we stop there. Okay, so let's go to our table. So now we're looking for 0 makes. Well, there's only one way to make 0.
You missed all 3 times.
Yep. 1, 2, 3. Miss, miss, miss. To figure out that probability, 0.4 to the third power, or 0.4. Let's write it's 0.4 to the third power because it's 0.4 times 0.4 times 0.4, right? And what do you get, Aldrin?
0.64.
0.64. Okay. And then the other one that only has one path is 3, right? All makes. Okay. Okay. So that's 0.6 to the third power, or 0.6 cubed, which is 0.216. 0.216. Okay. The middle two, you got to do a little bit of work because there's multiple ways to make 1. There's multiple ways to make 2. Okay. So let's go through. Let's do pick a different color. Okay. So we'll do one make. We'll do the paths for one make. So that means a make, miss, miss. That's 1. Let's see. A miss, make, miss. That's 2. And then miss, miss, make, right? 3 different ways to make 1 shot. All of those, in the end, they only make 1 shot. So what do we get? What numbers do we multiply for each?
0.6 times 0.4 times 0.4.
Mm-hmm. That's for each. We have the same probability for each. So we're going to multiply and add. Okay. So if I multiply 1, what do I get?
0.096.
0.096. 6. Okay. And if I add them all up,
0.288.
and then the only other thing that could happen is 2 makes, right? So you can add them all up, divide or subtract it from 1. What's this one going to be?
So 0.432.
432. Thank you. So they all should add up to 1 whole.
Yep.
Okay. Done that before many, many times. Okay. So now, based off of that, we got to answer some questions here. So the first question is find the probability m equals 0. Well, it said m is makes. So what's the probability that makes are 0? 0.064. It's right off the table. Less than 2. Which numbers are we talking about if we say less than 2?
0 and 1.
Right here.
0 and 1.
Only 0 and 1, right? So if I add those two guys up, I get 0.3 something. Okay. Less than or equal to 1. Which ones are less than or equal to 1?
0 and 1.
Same ones, right? So it's the same probability because it's this different way of asking the same question. Greater than or equal to 2.
2 and 3.
These guys right here. So I add those up.
0.648.
Okay. So we've done that before, right? We've done similar to this, not, different types of questions, but we've done that. That's what we did earlier, chapter 5, and then earlier in chapter 6, right? Okay, so today what we're going to do is that. This is all we're going to do, this, but on a grander scale. Okay, so let's take a look at this problem here. Sounds very familiar, but what's the difference between this problem and the problem you just did?
17 more times.
Yeah. How many shots did she take it? This is my table for 3. How big do you think my table is going to be if I have to do 20, right? I can't even fit it, right? It's going to be microscopic if I do it, right? That's why for problems like this, we use binomial distribution, okay? If it's something manageable, do it the way you've been doing it. Do it this way. It's manageable that way, right? But you guys kind of saw that there's some patterns here, right? There's only one way for all makes. There's only one way for all misses. So it doesn't matter if it's 20 or if it's 20 shots or 3 shots. There's going to be some that are very, very much, there's some patterns here. And then even the ones where it's one make, right? These guys were one make. Weren't we multiplying the same exact numbers and we got the same answer, right? We just need to know how many paths there are, right? This one, there are 3.
There'll be, 9 on the next one?
Yeah, that's the thing. We have to know how many paths there are. If we can figure out how many paths there are, we can find one of them and then multiply, right?
Well, how much are here? How much are here?
How many different paths?
4, 5, 6,
1, 2, 3, 4, 5, 6, 7, 8.
2 are guaranteed to be miss or 3, so that leaves 18. Then there's 1 and 2, so divide by 2, so there'd be 9 paths for 1 and 2.
We'll find out. Okay, so we're going to do this problem, except we're going to do it using binomial distribution. Okay, binomial distribution. So turn the page on your notes, and I'll tell you what binomial distribution is and how to use it. So it helps us with these big, big problems that I don't want to have to do a tree diagram for 20 things, right? So in order for us to use this, there's 4 conditions. There's 4 conditions to be able to use it. The first one is binary. It has to be binary. Binary means there's 2 options, right? 2 options. That's why it's binary. Success or failure. So in our case, make is a success, right? Because that's what we want. Failure is a miss. Okay. Is there any other option with shooting a basketball in this problem? No, right? So that's why it's binary. Independent. All observations are independent. Knowing the results of one observation tells you nothing about the probability of the next. So if she makes the first one, what's the probability she makes the second one? Exact same, right? Probabilities are exactly the same. Just because she makes her first one doesn't mean the probability is going to change here. It stays, right? That's why it's independent. Okay, the next one. Fixed number of trials. Fixed number of trials. It means we know when she's going to stop. Like for the first problem, we knew she was going to stop after 3 shots. Do we know how many she's going to stop after the second one? 20.
Oh, okay.
20, yeah. All right. Fixed number. So there has to be a fixed number of trials. That's what we call n. So if you see n, that's the fixed number of trials. Okay? Success. The probability for success is p, remains the same for each trial. So was the probability of success always the same?
60%.
Yeah, it wasn't. If a make is a success, wasn't the probability always 60%? It never changed, right? Okay. So if those all check out, we can use binomial distribution. Okay. The nice thing about binomial distribution is that your calculator will do it. It's not hard because your calculator does it.
Oh, you're right.
And even if you forget how to use it, this formula is given to you on the test. It's on your sheet. The sheet I gave you a few weeks ago, the blue one. Remember the blue one?
Yeah, but I don't know how to use that.
It's right there. I'm going to teach you how to use it.
Calculator knows how to use,
Your calculator knows, and you'll know how to do it by the end of today. Okay?
know how to play.
Okay, so the mean and standard deviation, don't worry about. We'll come back to those. Okay, but this is how we use it. Okay, so x. K is the number they're curious about. Okay, so if they ask you a question, so like, for example, K would be 0 here, K would be 2 here, 1 here, 2 here, right? They're the number they're asking the question about. Okay, that's what K is. The next one, N. What is N again?
Number of trials.
Fixed number of trials, right? How do I know that? It's written right here in your notes. Okay. K. K is, what was K again? Oh, K is the number of successes. Number of successes. Okay, so let's write that one down. That one's not labeled yet. Number of successes. Right? It's the same number as here. Those are okay. So whatever number's there goes at the bottom. So this part here. Oh, and then N is the number, right? And P is probability of success. It's right here. Okay. Okay, so this part here, probability of success, how many successes? Right? So whatever the probability of success is, to the how many successes are we going to have, times 1 minus P. In other words, the probability of failure. For the rest, N minus K. So if there are 20 here, and we want to know 5 successes, it would be P to the 5th, and then this one would be 15 because it's 20 minus 5. So these two numbers added up should equal this number here. These two added up should equal this number right here. Okay. Okay, so this part. So this part right here. This is what we call a combination. A combination. This will tell us how many ways down the path, how many paths there are on a tree diagram would give us that, right? Like the one we did earlier. There was one path for all makes. There was one path for all misses. There was 3 paths for one make. And then we didn't do 2 makes, but there are 1, 2, 3 as well. Okay, that'll tell us that. So if they want us to do 20 shots, it's a little hard to show on a tree diagram. So that's why we use binomial distribution. It's a faster way of doing it. Okay, so let's use it. Let's do an example here. Okay, let's do an example. The adult population of a large urban area is 55% women. If a jury is randomly selected from the adults in this area, find the following probabilities. Okay, so when you turn 18, your name is put into a pool of potential jurors. So if you get called, you get a summons, and they'll say appear on this day at this time. Whether you work, whether you have school, you got to go. Or else they put a warrant out for your arrest, and then next time they see you, whether you get pulled over or whatever, they can arrest you. Okay, and then you get a fine. So yeah, you have to go once you turn 18. You get a jury summons. Okay, so it's part of your civic duty. So anyway, this population, the total population in the city or whatever urban area is 55%. Okay, so they randomly select jurors. Right? They have a bunch of names in a hat, or they give each person a number. When your number calls up, you get a jury summons that says come in this day at this place at this time. If they choose you for a jury, you got to stay. Sometimes they don't choose you for a jury, you get to go home. Based on your answers that you give. Okay. So is this an example of binomial distribution? To answer that question, we always go back to the 4 conditions. Being selected on a jury. Is there only 2 options to be selected on a jury?
Yeah, you gotta do it.
You're either picked or you're not picked. There's nothing else. That's it. You're either picked for the jury or you're told, no, thank you. You can go home. Thanks for your service. Okay. Independent. Because it's a large urban area, it's always going to be independent. Okay. So knowing the results of one isn't going to change the probability of the other one. It's 1 out of whatever, right? Let's say in the valley, in Fresno County, there are about 1 million people. Okay. So adults, probably somewhere 700,000, right? So if they choose me, that's 1 out of 600,000, right? Let's say they choose me. Or let's say they don't choose me. The next one is 1 out of 599,999. If I put these numbers in the calculator, they're pretty much going to be the same number, right? 1 out of 600,000 and 1 out of 599,999, pretty much going to be the same, right? So they're independent. Okay, that's what that means. So just because I didn't get picked the first time means my probability is going to be the same. Okay? Because 1 out of 600,000 is the same, pretty much the same number, percentage anyway, out of 1 out of 599,999. Okay. Fixed number. There is a fixed number. What is the fixed number for a jury? 12. Yep. 12. There are 12 people on the jury. Probability of success remains the same for each trial. These two pretty much go together. Independent and success go together. So if one's true, the other's going to be as well. Okay. Okay, so this one, conditions. So we would write all 4 conditions are met. Okay. So the question says, what is the probability that 7 out of the 12 jurors are women? Okay. So now it's not asking probability I get chosen versus I don't get chosen. What is success going to be on this one here?
Women.
Choosing a woman. In this case, success is going to be having a woman chosen. Okay, so this is how we're going to set it up. We're going to say the probability x equals 7, because that's what they're asking us about. They're saying 7 out of 12. If I choose 12 people randomly, what's the probability that 7 of them are going to be females? Okay. NK, right? N goes at the top. So 12, choose 7. That'll tell me how many, this right here will tell me how many paths, right? Because if I were to do this using a tree diagram, it would be 12 events, right? Woman, so it would be woman, male, woman, male, woman, male, and it would be huge, right? So now the next one is probability of success. So what's the probability of success on this one? 55%, because 55% females. How many successes am I going to have for this one? 7. Yep, that's K, remember? K is this number, and this number. Times the probability of failure. What's the probability of failure? 45%. 1 minus that. So you can say 1 minus 55%, or you can just put 45%. Now, how many failures am I going to have? If I have 7 successes, how many failures am I going to have? Mm-hmm. Okay. That's what I need to see on paper. Now I'm going to show you how to do it on a calculator. Okay. All right. So let me get my calculator real quick. Okay, so we're going to calculate the probability that 7 out of the 12 are women. Okay. So in order to do this, we have to go to, I believe we're going to go to distribution. So find the distribution button in blue. It's in blue. I think on mine it's on blue. Let's see on the other one. While I'm loading mine up. Yes, it's on blue.
Oh, second vars?
Vars, right above vars. Yep, right above vars. Okay, right above vars, right below the down button, the down cursor.
We're looking for binomial PDF?
And we're looking for, there's 2 of them, right? There's a binomial PDF and there's a binomial CDF. We want PDF for this one.
Nice.
We'll use CDF later, but for right now, I want PDF. Okay. You're going to hit enter. Does anyone's not give you this one? Does anyone's not? Okay, so the rest of you, this is what it shows? Okay, so hang tight if you don't have this. If you do have this, trials. 12 trials. P, probability of success, 55. X value, 7. That's K. They call it X, but it's really K. Okay, so if you don't have this, this is what you're going to put. It should say binom PDF, parentheses.
I'm gonna have to spell out binomial.
No.
Here's some information.
You just hit binom. Some of our calculators, if they're the older software. So if they're the older software, they don't give you some of the features. It does the same thing, but it's different steps to get there. So you put in N. So some of these calculators, like I said, it's kind of a crapshoot. You grab a calculator, it might have old software. It still does everything, but some of the features are different. You have to find them in different spots. Okay. So if you don't have your own calculator, make sure you know this, because on tests I can't help you with this stuff. Okay. So if you have your own calculator, you're good. But if you don't, if you're using one of those, like I said, it's a crapshoot whether it's got new stuff or an old stuff. Okay. So you hit enter. That's the probability.
Alright. Should've told us this earlier.
Okay. So n is the first number, 12. P is the second one, 55%. K is the last number. Okay. All right, so let's go back to the notes. Okay, so there is a 22.2% chance of 7 women being chosen. Okay. For which value of k? So for which value, for which number here, would I expect the probability to be the highest?
1, 6, oh. 5? 55.
Because it's 55% total, right? What's 55% of 12?
12. Oh, wait, 55% of 12? Yeah, 6.6.
So around 6, right? So between 6 and 7, I would think those are the highest bars there. So this is probably going to be one of the highest probabilities. Okay. Okay, so what's the probability of less than 3 women? Okay. So we're going to write it like this. The probability x less than 3.
The same as
So when we say less than 3, what are we talking about?
everything. 0, 1, 2, 3.
There you go. So we're actually asking for the probability x is 0, no women, plus the probability x is 1, right? 1 woman, plus the probability 2 women. And stopping right there, right? That's what we're looking for. So really it's 3 problems, and then I add up their answers. Okay. So there's a quick way. If you have one of those graphic calculators, there's a quick way. If you don't have access to one, it's going to take you a little longer, but you can do it. You can do it. Okay. So we're going to go back to our calculator, back to distribution. Okay, we're going to go down to binomial, except this time we're going to choose CDF. Why are we choosing CDF? What does a C stand for? Cumulative. 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 What does the word cumulative mean?
Add it all together.
Add it all together, and that's what we want to do, right? We want to add it all together. The thing about cumulative is it starts at 0 and goes to the number we want it to stop. Okay. So fixed number of trials. 12. Still a 0.55 probability. Where do we want it to stop counting? From 0, not at 2. We want it to stop at 3, right? So we want it to count 0, count 1, count 2, stop. So stop at 3. So we're going to put 3 here. Okay. So N, P, K, N, the total number 12. 55 is the probability of success. K is the number I want you to stop at. So I want you to count the probability of 1, 0, 1, 2, add them all together. There it is. 0.036, yep. So there is a 3.6% chance of less than 3 women chosen. Less than 3 women chosen. Okay. So that's the difference between PDF and CDF. PDF on your calculators, we're only looking for one number, 7. That's it. Probability of 7, no more. CDF, we're looking for add up the numbers. Because here we wanted probability of 0, probability of 1, probability of 2 all together. Add them up all together for me. Okay. So let's say, before we go into the next one, let's say this one was different. Let's say it was greater than 3. Let's say they wanted me to find this. How would I do that on the calculator? Greater than 3 means 4, 5, 6, 7, 8, 9, 10, 11, and 12. Add up all of those.
Well,
right?
You said it starts at 0, right?
Starts at 0, yep. This is what I want. Oops. Because this is going to happen too. So, dot, dot, dot. That's what I want. That's what that means. How do I do that? Using the calculator. Binomial, CDF, right? Still a CDF question because I want to add them up. But how would I do it using the calculator? What number would I put in for K?
Would you just put 4 and then minus it by 1?
There you go. That's what you would do. Yep. You wouldn't put 4, actually, you put 3.
I thought you said you stop at.
Wait.
Stop at 4.
Wait, what did I say? 0.
But you're doing greater than 3, right?
Greater than 3, so 4. So yeah, you would put 4. Yeah, you put 4. Yeah, you're right. So you would put 4 and then 1 minus that. So you would put 4, you would put binomial 12, comma 55%, 0.55, and then you do 4.
And then 1 minus it.
And then that would be like the opposite of your answer, and then you go 1 minus that. Yeah. Okay. So if you forget it, that's why it's being recorded right now, so you guys have it to refer to. Okay, so now let's go to the last question for this problem. How many jurors would I expect to be women out of the 12? So how many would I expect to be women out of the 12? So when I say expect, how many would you expect there to be?
The mean.
That's the mean, right? That's the mean. So if we go back to the formula page, there's another one that you do not have to memorize because it's given to you.
N times
N times P. N is the number of fixed trials, so 12 times probability of success, yeah.
6.6.
Which is what we said earlier, right?
I think so.
12.55. What do we get?
Oh, 6.6.
6.6. So theoretically, 6.6. In real life, between 6 and 7. I would expect between 6 and 7 women. It's okay to say 6 or 7 when you have that number, okay? Because this is your data to back it up, okay? I can't just not have this and say between 6 or 7. I have to have 6.6 somewhere in there. If I want to, like I said, if I want to say in my statement, I would expect, not between, 6 or 7 women on the jury. That calculation kind of sums that. That's what it's just referring to that. Okay, it's the interpretation is referring to 6.6 because it kind of sounds funky to say there would be 6.6 women on the jury. How do you have 6.6 women, right? So in plain English, it means 6 or 7, right? 6 or 7. Okay. All right. So I want you to try the next one. Do the next one on your own.